Homework 1 for Chapter 20. A sample of ideal gas through the process shown in figure. From A to B, the process is a adiabatic process. From B to C is an isobaric process with 100 kilojoule of energy enter the system by heating. So this part is a heat energy for the process B to C. And from C to D, the process is isothermal process. From D to A is isobaric with the 150 kilojoule energy leaving the system by heat. So at D to A is a heat loss from the system about 150 kilojoule. So determine the difference in internal energy UV minus UA. So the difference of internal energy UV minus UA is the internal energy change from process A to process B. So if we consider the internal energy for the cycle from A to B, B to C, C to D, and D back to A is a full cycle, then the internal energy change will become zero because the thermodynamic parameter is the same for the PV and T, then the internal energy is the same. If we consider from the first law of thermodynamics, internal energy change from the process A to B equal to heat for the process A to B minus work from the process done by the system from the process A to B. So we have the same for the process B to C, C to D, and D to A. This stated by the first law of thermodynamics. For the process from state A to state B is an adiabatic process. In adiabatic process, heat exchange between system and environment is zero, then QAB is zero. Then the internal energy change equal to the work in this process A to B. And for the process C to D is isothermal process. For the isothermal process, the internal energy change is zero. Then we have delta UCT equal to zero. So then we can put these two conditions into the internal energy change for the whole cycle as delta UAB plus QBC minus WBC plus 0 plus QDA minus WDA equal to 0. So this is a total energy change for the full cycle. As we done from the last slide, we just substitute these two conditions into the equation. From this equation, we rearrange the equation. We have delta UAB equal to minus QBC plus WBC minus QDA plus WDA. If we combine each together and work together, we have something like this. And from the condition of the problem, we have heat for the process BC is 100 kilojoule into the system. And for the QDA is a heat loss from the system minus 150 kilojoule. And for the work for the BC process, we can look from the PV diagram. PV diagram show that for the B to C, pressure is at 3 atm. And the volume change is from 0.09 to 0.4. Then volume change is 0.4 minus 0.09 square cubic meter. And for the work at the process D to A is an isobaric process with 1 atm pressure, the volume change from 1.2 to 0.2, then the delta V is 0.2 minus 1.2. And we want to calculate in Joule, then we change from atm to kilopascal. Then we just count it with 101.365 kilopascal. From this, you put into the calculator. We can calculate for the internal energy change for the state A to B equal to 42.90725 kilojoule.